In this IGCSE CIE talk-through, we're going to be going through paper 2, the multiple choice paper, which is an extended paper. This is from November 2017. Which statement describes sublimation? So remember, with sublimation, we're going from a solid directly into a gas. In a solid, the particles are close together. Remember, they vibrate slightly. And then in a gas, they move far more quickly, far further apart. So let's have a look. Which answer is that? I'm not going to read out all the options in this particular question because they all sound so similar and strange. I'm going to go directly in at the answer, which is C. Particles vibrating next to each other start to move rapidly and then move further apart. Annoying question to start off with, CIE. 2. 25 centimetres cubed of an alkali are added to 20 centimetres cubed of an acid. The temperature change is measured. Which apparatus is not needed in the experiment? So you've got this kind of setup where you've got a polystyrene cup, the substances are inside the cup, you're looking at the temperature change, so we need to use a measuring cylinder in order to measure the volumes, the beaker probably to pour them into each other, a balance, no, we haven't mentioned anything to do with masses, a thermometer, yes, I've drawn one appallingly, so the thing we don't need is the measuring balance. The painkiller paracetamol is synthesized from 4-aminophenol. Chromatography was carried out on an impure sample of paracetamol. The results are shown. So S is the impure sample of paracetamol, P is the pure sample. The sample of paracetamol was contaminated with 4-aminophenol only. What is the RF value of 4-aminophenol? Okay, so the contaminant is this blob here. So remember, to find out the RF value, we need to measure the distance that that particular dot has moved and then divide it by the distance that the solvent has moved. So to pull out those values, you've got the values here, that's helpful. 0.26 divided by 0.35. And once you've done that, you get a value which is 0.74. So the answer again is C. They're trying to trick us with 3 C's into thinking that one of the C's is wrong. I know your game, CIE. 4. Which compound is silicon 4 dioxide? So this is a giant covalent structure. We've got 2 nonmetals. It's found in sand. So therefore it has a high melting point. I love writing notes to myself. It's a poor conductor, both when solid and molten. So looking at the melting points, C and D are high. We need know from the conductivity point of view when solid and when molten, which is why D is the answer. 5. Carbon has 3 naturally occurring isotopes. 12 carbon, 13 carbon, 14 carbon. Remember that an isotope has the same number of protons, the same number of electrons. The crucial difference here is that they have different numbers of neutrons. So what does the question ask us? Which statement explains why isotopes have the same chemical properties? Well, chemical properties, you must learn, is always related to the number of electrons in the outer shell. So, A, they have the same number of electrons in the first shell. Irrelevant. B, they have the same number of electrons in the outer shell. Yes, let's check. C, they have the same number of neutrons in the nucleus. I've said here that they have different numbers of neutrons, so that's not right. They have the same number of protons as neutrons. Nope. 5B. Which dot and cross diagram shows the outer electron arrangement in a molecule of carbon dioxide? I'm just going to draw carbon dioxide over here so you can see how I've arrived at my answer. Carbon has 4 electrons in its outer shell. I know that carbon dioxide has double covalent bonds, so I'm doing this. And then oxygen has 6 electrons in its outer shell. Which diagram matches mine? It's A. The equation represents the reaction between solid magnesium oxide and dilute hydrochloric acid to form magnesium chloride and water. Which row shows the state symbols for hydrochloric acid, magnesium chloride and water? Now, we know that magnesium oxide is solid, it's told us there, so don't ignore the question. Hydrochloric acid is an acid in solution, so it's aqueous. Magnesium chloride is a soluble salt, so it's aqueous. Water is a liquid. Looking along the rows then, we know that hydrochloric acid is aqueous. Magnesium chloride, I said, is aqueous. Water is a liquid. The answer here is 7A. The compound contains 34.5% calcium, 24.1% silicon, and 41.4% oxygen by mass. What is its empirical formula? So to do this, I'm going to do it up here so I have more space. Look, I've made my pen nib narrower. It's a big day for Hazel. Remember, we always lay out our empirical formulae calculations in the same way. Make sure you watch my very popular moles video if you struggle with more calculations. That will clear it up and show you why I'm doing it like this. Our masses, well, because we're giving them as percentages, but it doesn't matter, we can pretend that they're the masses, so we just copy that straight into the table. Use your periodic table to find out the MR of these various elements. So calcium is 40, silicon is 28, oxygen is 16. We use this formula triangle to help us find out the number of moles, which shows us that number of moles is mass divided by MR. So just do 34.5 divided by 40 to get 0.8625, 24.1 divided by 28 to get 0.8607, 41.4 divided by 16 to get 2.587, and then to find a ratio you just need to make one of those numbers equal 1, so we divide by the smallest number. The smallest number is 0.86. I can see straight away that there'll be 1, so 2.5 divided by 0.86 equals 3, so our ratio is 1 to 1 to 3, so our formula is CaSiO3. So we're ready to find that in our answer, which is B. Which statements about the electrolysis of concentrated copper 2 chloride are correct? Number 1, electrons are transferred from the cathode to the copper ions. Remember that the cathode is the negative electrode. We know that the copper 2 ions become copper atoms through the addition of electrons. So this is true. Electrons move around the external circuit from the cathode to the anode. This is false. It's the other way around. The electrons always flow from the anode to the cathode. Chloride ions are attracted to the anode, while the anode is positive electrode. Chloride ions, remember, have a charge of Cl-, opposites attract, so this is true. Hydroxide ions transfer electrons to the cathode, that's false. So the answer is 1 and 3A. Which metal combination produces the highest voltage reading in the cell shown? Your key here is knowing the reactivity series. Effectively, you want the two metals with the greatest difference in reactivity between them. So C is not the answer because you've got copper and copper. Nope. So now it's a matter of choosing between iron, zinc and magnesium. Which one is the most reactive? Well, that's magnesium, so therefore the answer here is D. 11. Some bond energies are shown in the table. Hydrogen reacts with oxygen. The reaction is exothermic. What is the energy change for the reaction? Okay, I find it easiest to draw out the various bonds so I can actually see them. And then I write bonds broken, which is 2 lots of hydrogen. So from the table I can see that that's 436 plus 1 lot of oxygen, so that's 496. We add those together to get 1368. And then we look at bonds made. So we have 4 lots of the OH bond, so 4 times 460. The reason I said 4 lots is there's 1, 2, and then times it by 2 due to that 2. Let's add that up to get 1840, and then I do 1368, take away that answer to get minus 472 kJ per mole. Muchos working for only 1 mark. The answer here is C. Which statement describes an exothermic reaction? Okay, you have to know this off by heart. We know that heat energy is released, and you also need to learn that the energy absorbed for bond breaking is less than the energy released by bond formation. So the answer therefore is B. The mass of a beaker and its contents is plotted against time. Which graph represents what happens when sodium carbonate reacts with an excess of dilute hydrochloric acid in an open beaker? I'm just going to quickly write out the chemical equation for you so you can actually see what's going on. There's sodium carbonate reacting with hydrochloric acid to form sodium chloride plus water plus carbon dioxide. Notice that the carbon dioxide is a gas. It will escape, which means that the mass decreases over time, a reaction always takes place more quickly at the start due to the fact that there are more particles present. So this graph line B shows this happening. We can see that the mass is decreasing and that it occurs more quickly at the start here due to the steeper gradient. Silver chloride reacts when it's exposed to light. Which row shows what happens to the silver in this process? Well, silver chloride is made up of silver ions and chloride ions, which is why we need to have silver on the left-hand side of our equation. We're adding electrons to it. Remember, oil rig, oxidation is loss of electrons, reduction is gain of electrons. We've gained electrons, so reduction has taken place. Which row matches up with what I've just written? Well, that's D. Which statement about the effect of concentration and temperature on the rate of reaction is not correct? If the concentration of a reactant is increased, the rate of reaction increases because more particles have sufficient energy to react. No, altering the concentration has no effect on how much energy the particles have. It just means that there are more particles in the same volume when you increase the concentration. B, if the concentration of reactant is increased, the rate of reaction increases because there are more collisions between particles per second. Yeah, I like that answer. If the temperature is increased, the rate of reaction increases because there are more collisions between particles per second. Yep, that's true. If the temperature is increased, the rate of reaction increases because more particles have sufficient energy to react. Yep, increase in the temperature does alter that. So which one is not correct? A. The following reaction has reached equilibrium in a closed system. The forward reaction is exothermic, so delta H is negative. Which row shows the effect of increasing the pressure on the equilibrium mixture? Oh, we don't need to know about the exothermic. That has nothing to do with pressure. We simply need to count the number of moles of gas on the left-hand side versus on the right-hand side. So there's 2 plus 1, so 3 on the left-hand side, 2 on the right-hand side. So if we increase the pressure, the system will try to oppose the change, which means that the position of equilibrium shifts to the right, meaning that there's more SO3 made. Because we've increased the pressure, we're also going to increase the rate of reaction by definition. So looking along here, increases, SO2 will by definition decrease, and that's because the amount of SO3 has increased. So the answer here is A. 17. Some properties of 4 oxides are listed. Oxide 1 reacts with both acids and alkalis to form salts. Oxide 2 reacts with acids to form salts, but it does not react with alkalis. I hate these questions. I hate them. They're so hard. They're all the same but slightly different. Oxide 3 reacts with alkalis to form salts but does not react with acids. Oxide 4 does not react with acids or alkalis. Which row describes the oxides? So amphoteric means that it can either be acidic or basic, which is helpful, and will therefore react with both acids and bases. Because oxide 1 reacts with both acids and alkalis, we know that it could be amphoteric, so we're going to go along these 2 rows. Looking now at oxide 2, reacts with acids to form salts but does not react with alkalis. Well, it's going to have to be the opposite of an acid in order for it to react, so it needs to be basic. And I mean, now we've already ticked those 2 off, we know that it has to be B. Let's just check 3. Oxide 3 reacts with alkalis to form salts but does not react with acids. Yeah, it's going to be the opposite of an alkali, so it's going to be acidic. Oxide 4 does not react with acids or alkalis, it must be therefore by definition neutral. 18. What is not a typical characteristic of acids? They react with alkalis producing water. Well, they do that. They react with all metals producing hydrogen. No, that's wrong. Metals beneath hydrogen in the reactivity series will not react with acids. So actually I'm going straight in at 18B. 3 solids, P, Q and R, all react with dilute sulfuric acid to produce zinc sulfate. P and R produce gases during the reaction. The gas produced when P reacts does not burn. The gas produced when R reacts will burn. What are P, Q and R? The gas is likely to be either hydrogen or carbon dioxide. Now, if it doesn't burn, then that's carbon dioxide, because remember, carbon dioxide does not support combustion, which means that P must have contained something which would later produce the carbon dioxide. So P is therefore the carbonate. The gas produced when R reacts will burn, so we know that that gas must be hydrogen. It's a metal by itself that produces hydrogen, so I'm thinking that's going to likely be zinc. The reason I know it's zinc is because of this bit here, and therefore I'm kind of ready to go because I know that R is zinc, I know that P is zinc carbonate, and so where have I got double underlining? Well, that's on C. Just double check that Q is zinc hydroxide. Yeah, well, sulfuric acid plus zinc hydroxide would produce zinc sulfate. We don't have any more information, so I'm going to just stick with 19C. Which ion forms a green precipitate with aqueous sodium hydroxide that dissolves in an excess of aqueous sodium hydroxide? Okay, learn this off by heart. It is the chromium ion. A period of the periodic table is shown. The letters are not their chemical symbols. Which statement is correct? Okay, so we've got the metals over here, the non-metals over here. Remember that metals produce basic oxides. I'm just making a few notes to myself. I haven't even looked at the question. Just getting my eye in, as I always say. Which statement is correct? Element R does not conduct electricity. Well, it's a metal, so it would conduct electricity. Elements R and Y react together to form an ionic compound. I mean, that, because it's in group 7, could be something like chlorine. R is in group 1, so it could be something like sodium. So that would be sodium chloride, which is an ionic compound. Element Z exists as a diatomic molecule. No, it's monatomic. It's in group 8. Element Z reacts with element T. Group 8 elements don't readily undergo reactions because they have full outer shells, so no. The answer here is B. Some properties of element X are shown. In which part of the periodic table is X found? Now, the fairly low melting point and the fact that it has a fairly low boiling point. Now, because it reacts with cold water, it has to be pretty reactive. So really it's shouting group 1 elements at me, because remember they give off hydrogen gas when they react with water, so that's A. The table gives some properties of an element. It has a high melting point, it's grey, has a dark blue chloride, quite a high density, and it has good electrical conductivity. I'm thinking because it has a high melting point, the fact that it's grey, the fact that it has good conductivity, that it's probably a metal. I think it's going to be a transition metal, which remember forms coloured compounds and can act as catalysts. It won't be brittle because it's a metal, so 23A. It won't be an acidic oxide because it produces basic oxides, and it won't be highly reactive with water. Why is argon gas used to fill electric lamps? It's because it's really unreactive. What is a property of all metals? They conduct electricity, yes. They're not all hard. Mercury is soft. They have low melting points. No, lots of them have high melting points. They react with water. Not true. Gold doesn't. 25A. Aluminium is obtained by the electrolysis of a mixture of aluminium oxide and cryolite. Why is cryolite used? Remember that the aluminium oxide dissolves into it, so it therefore acts as a solvent. Metal M is mixed with copper to produce brass. What is M? Oh, you do need to learn your alloys. So in order to produce brass, you need both copper and zinc. Some metal nitrates and carbonates decompose when heated strongly. Metal Q has a nitrate that decomposes to give a salt and a colourless gas only. The carbonate of metal Q does not decompose when heated with a Bunsen burner. What is metal Q? Crucially, it's the fact that the carbonate of this does not decompose, so it's definitely not calcium carbonate, because we know that decomposes to calcium oxide and carbon dioxide. We know that both copper nitrate and copper carbonate decompose when heated, and actually it's sodium whose nitrate decomposes to give a salt and a colourless gas, but doesn't decompose when it's in the carbonate version of itself, so it's C. 29. The flowchart shows stages in the treatment of river water to produce drinking water. River water followed by the settling tank, followed by... They ask this so often, you've got to learn it in exactly this way. I've seen this question so many times. They filter it in order to remove solids, and then they add chlorine to it to kill pathogens. So we're looking for filtration followed by chlorination, so C is the answer. A piece of zinc is attached to the hull of a steel boat. Steel is an alloy of iron. Which statement explains why the zinc prevents the iron from rusting? Okay, they do this because remember it's sacrificial protection, and it works by the zinc reacts before iron. So effectively you form Zn2 plus ions. And remember that equation can also be written in this way. So which statement explains why zinc prevents the iron from rusting? A, zinc is less reactive than iron. Okay, the moment I see that, it's wrong. Don't need to read anything else. Again, B, zinc is less reactive than iron. No. C, zinc is more reactive than iron. The iron is less likely to lose electrons than zinc. Yeah, that's effectively what my equation is showing. Just a different way around of putting the same thing. So it's actually C. D, zinc is more reactive than iron, and iron is more likely to lose electrons than zinc. If that were true, then it would react away, and therefore the zinc would be completely pointless. The Haber process for making ammonia is carried out at a temperature of 450 degrees Celsius and a pressure of 200 atmospheres in the presence of a catalyst. Which statement is not correct? So remember, this is our equation for the Haber process. So reversible reaction produces ammonia. Notice that the forward reaction is exothermic. So to favour ammonia production, we need a low temperature and a high pressure. So which statement is not correct? Lowering the pressure increases the rate at which ammonia is produced. Well, that's obviously wrong because increased pressures increase the rate. So it's actually this one because it's not correct. 31A. I didn't really need to do all my other thing. If A hadn't been the answer, then I would have had to have gone through all the other options, then my notes would have been useful. 32. Which process does not produce carbon dioxide? Well, the combustion of methane, remember you're burning in oxygen to produce carbon dioxide and water. So it does produce carbon dioxide, which is why methane is not correct. Photosynthesis now, remember plants use carbon dioxide and water to produce glucose and oxygen. So because that carbon dioxide is on the left-hand side of the equation, we're using it, so it's not producing it, so it's B. Which row shows the conditions used in the manufacture of sulfuric acid by the contact process? Now this is a simple factual recall question. Make sure you've learnt your reaction conditions. We're looking at a high temperature of 400 degrees followed by low pressure, and then crucially it's a vanadium 5 catalyst. 33D. Some marble chips, calcium carbonate, are heated strongly and substances X and Y are formed. X is a white solid, so I know that's calcium oxide that reacts with water giving out heat. Substance Y is a colourless gas. So just to show you, calcium carbonate thermally decomposes into calcium oxide and carbon dioxide. So X is calcium oxide, Y is carbon dioxide. The answer here is C. The structural compound R is shown. What is R? Okay, we have 3 carbons in a row, so monkeys eat peanut, so we have prop. It's an alcohol because of that OH group, so it's propanol. C. Fuel oil and naphtha are 2 fractions obtained from petroleum. What are the major uses of these fractions? Again, just learn this for me. Fuel oil is ship fuel, whereas naphtha is used for making chemicals. So C. X, Y and Z are 3 hydrocarbons. What do compounds X, Y and Z all have in common? They're all alkenes, yes, because they have this carbon-carbon double bond. They're all alkenes. They're all part of the same homologous series. For sure, they're all alkenes. That is their homologous series. They all have the same boiling point. No, remember that members of the same homologous series have the same chemical properties, but different physical ones. And linked with physical properties is their boiling points. They will not be the same. So 1 and 2 is correct only, so B. The diagram shows a reaction sequence. Which row names the processes X, Y and Z? Well, we're going from butane, which is C4H10, to ethene, which is C2H4. So that is a cracking reaction because we're breaking up long hydrocarbon chains into smaller ones. Then we're going from an alkene, ethene, to an alcohol, ethanol, so we're hydrating because we're adding water effectively. And then lastly, we're producing carbon dioxide and water from that ethanol, which means we're carrying out combustion because we have to burn it in order to produce that. So B is the answer. The structure of an ester is shown. What combination of carboxylic acid and alcohol produces this ester? Okay, this one, attached to a single oxygen bond in the ester bond, forms the alcohol. So if I redraw it, we've got 4 carbons, an O. I'll just complete the hydrogens quickly. Now remember that that single bond O is where the alcohol joins on. So this is our first alcohol. There are 4 carbons, 1, 2, 3, 4. So it's butanol. Looking now at the other side of the molecule, this side, that's our carboxylic acid. So I just need to turn it back into a carboxylic acid with this functional group over here, the carboxyl functional group. How many carbons do we have in a line? 3. It's a carboxylic acid, so it's propanoic acid. So the answer here is D. The equation shows the formation of a polymer called Kevlar. Which row describes Kevlar? Now we crucially notice we're losing water, so that means it must be a condensation reaction. And then this molecule down here is a polyamide. I know this because of this functional group here. So my answer therefore is C.